So think about the giants. Facebook, Google, TikTok. What's one thing they all have in common? Well, besides having a bajillion users, they all ran into the exact same massive problem that comes with that kind of success. What do you do when your database just can't keep up anymore? Today, we're going to break down the brilliant engineering solution they all use, a concept called sharding.
Okay, so let's put you in the driver's seat. Imagine you did it. You built the next big thing, some social app that has absolutely exploded. You've got 1 billion users. I mean, congratulations, but uh-oh. Behind the scenes, that single giant database you started with is starting to creak and groan under the weight. And this isn't just some hypothetical, this is a real-deal crisis just waiting to happen.
And yeah, this is exactly the point where that amazing success story suddenly becomes a 5-alarm fire for your engineers. That incredible growth you were celebrating is now pushing your entire system to its absolute breaking point.
And you really start to see the cracks forming, right? Your users start complaining. Their feeds take forever to load because the database is literally trying to sift through 1 billion profiles just to find their friends' latest posts. Then, when someone tries to upload a photo, that write gets stuck in a massive digital traffic jam. Even the indexes, the very things that are supposed to speed it all up, have become so monstrously huge that they're now part of the problem. But here's the real kicker, the thing that keeps engineers up at night. Your entire app now has a single point of failure. If that one database goes down, everything goes down.
So you're probably thinking, okay, easy fix. Let's just buy a bigger, badder server, right? And yeah, for a while that actually works. But you eventually hit a hard physical wall. I mean, even the beefiest, most expensive cloud databases out there top out at around 256 terabytes. This whole approach, what engineers call vertical scaling, has a ceiling. You literally can't buy a bigger box.
So this is a really crucial point to understand. The old strategy of scaling vertically, just making one server more powerful, it's a dead end. It runs out of road. The only real path forward is to start thinking differently, to scale horizontally. And that just means spreading the workload across lots and lots of smaller servers instead of one giant one.
And that brings us to the hero of our story, sharding. This is the core concept that lets systems like Instagram, Amazon, and Google handle these unimaginable amounts of data. It's all about not putting all your eggs in one very fragile basket. So what is it really? Well, in a nutshell, sharding is this simple but super powerful idea. You're not just copying your data, you're strategically breaking it up into these smaller, independent pieces called shards. And you can think of each shard as its own little mini database, fast, efficient, and way easier to manage.
So how does this magic actually work? Well, think of it as horizontal partitioning. All the shards have the exact same structure, the same tables, same columns, all that. The difference is they each hold a unique set of rows. And the secret sauce that makes it all work is something called the shard key. The shard key is basically like a zip code for your data. When a request comes in, the system doesn't have to search the whole country. It just looks at the zip code and knows exactly which neighborhood or shard to go to.
Okay, so that's the high-level theory. Let's get into the nitty-gritty and see how this actually gets put into practice for our billion-user app. And wow, this visual just says it all, doesn't it? On the left, you've got the problem. One massive, slow, fragile database just waiting to fall over. And on the right, you have the solution. A whole fleet of smaller, faster, and much more resilient databases, where each one is only responsible for a small fraction of the total load. It's a total game changer.
Now, probably the simplest way to get this done is with something called range-based sharding. We just use the user ID as our shard key. So, as you can see, all users with IDs from 0 to 999, they go into shard 1. Users from 1000 to 1999, they live in shard 2, and so on. It's clean, it's super logical, and it's really easy to know exactly where to find somebody's data.
But, that range-based approach isn't perfect. What if your newest users are also your most active users? Well, all of that new traffic would just hammer that last shard, creating what's known as a hotspot. To avoid that kind of problem, most big systems use a much smarter method called hash-based sharding, which does a way better job of spreading the data out evenly.
Okay, now this formula might look a little intimidating, but I promise you the idea behind it is super simple. You just take some piece of data, like the user ID, and you run it through what's called a hashing function. It spits out a number that seems random, but it's always the same for the same user ID. Then you use this modulo operator. All that does is give you the remainder after you divide by the total number of shards you have. It's kind of like dealing cards to a bunch of players. The modulo makes sure that no matter how many cards are in the deck, every player gets a roughly equal hand. And that simple little trick is what prevents those dangerous hotspots.
So after all that technical stuff, you might be asking, why go through all this trouble? Well, because the payoff is just massive. Let's connect this whole solution back to the real-world benefits you get.
Remember those feeds that were loading so slowly? Now they're lightning fast, because any query only has to look through a tiny slice of the data. Worried about that single point of failure taking down the whole app? Well, now, if one shard has a problem, only a portion of your users are affected. The rest of the system just keeps humming along. And maybe best of all, you've unlocked almost infinite scalability. Need more capacity? You just add more shards. It's that simple.
But it's really important to have a balanced view here. Sharding is an incredibly powerful tool, for sure, but it's not some magic wand you can just wave. It solves that huge scaling problem, but it does so by introducing a whole new set of pretty complex challenges.
For instance, adding a new shard isn't as simple as just plugging one in. You have to carefully rebalance all the existing data across the entire system, which is a tricky process. And what happens if you need to ask a question that needs data from multiple shards at once? Well, those kinds of queries can be really slow and expensive. And your application itself has to get smarter. It needs to be shard-aware so it knows exactly which shard to talk to for any given request.
So let's just zoom out and recap this whole journey we've been on. It's a pretty classic 3-act story, right? It starts with a single database hitting its absolute limit, a hard wall. The solution is sharding, which intelligently splits up the data and the workload. And the result? A system that's no longer stuck, one that can grow to meet almost any demand you throw at it.
Sharding was this absolutely brilliant answer to the scaling challenges that came with the web and mobile boom. But as we start looking at an age of AI-generated content, the metaverse, and who knows what else, the sheer amount and complexity of data is reaching another one of those tipping points, and it leaves us with this one big question to think about. What comes next? What's the new engineering breakthrough that will be needed to solve the next billion-user problem?